Well, good morning, everybody. It's good to see that I was able to fill up the room. I hope maybe the keynote speaker from yesterday was able to do that for me, because he also showed some things about scripting output and using that to plot diagrams and stuff. So maybe that inspired you to come here. The session for today will be a hands-on session, so I hope everybody will have a laptop or at least some form of doing the exercises. The purpose is to get to know the Wireshark CLI tools and how you can use them to create custom format output and some statistics and stuff like that. Well, the agenda for today, first some introductions. Who are you? Who am I? Why do you want to use CLI tools? Maybe some people have ideas about that. How do you use them? Which CLI tools are available from the Wireshark distribution? Then we do a little hands-on about the Wireshark CLI tools, just use them plainly, what output do they have, what can you do with them. Then we start looking at some useful shell commands that we can use to enhance the CLI tools. I will give you some examples how to do that, and then you have to do it on your own. I have a whole list of cases that you can work on. And finally some questions and answers. Feel free to ask any questions if you want. If it takes too long, I will just put it to the end of the session, but feel free to ask a question when it comes up. So introductions. How many of you have ever used the CLI tools from Wireshark? Quite a few, yeah. And how many have used command line piping to use the output to put it into set, org, or whatever? A little less, but still some people. And well, that's what we're going to talk about today. So I'm glad that a lot of you haven't used it yet. So you might. Okay, who am I? I've been in the networking industry since 1995. I'm doing a lot of troubleshooting. I worked first for an ISP, then for a large bank, and the last 8 years for a reseller of load balancing products. And I really had to do a lot of analysis of bugs and protocol traffic flows that were quite peculiar. And since February, I started my own company to do troubleshooting in those areas. So I've been using Wireshark or Ethereal since 1999, and I've started developing in 2006, mainly some GUI stuff, some bug fixes, and also some dissector stuff. So that in my work, I use Tshark a lot to get the output I want, some statistics, and that's why I tried to give this session. So why should we use the CLI tools? Anybody has a clue?
Efficient.
Efficient, yeah.
Low resource.
Low resource, yeah.
You can automate it. More flexibility.
Flexibility, exactly, yeah.
Faster.
Huh?
Faster.
Faster, yeah. Not always, but. So sometimes you don't have a GUI. I mean, you're in a system and you don't have a GUI, so that's one of the reasons. I think that's the first one that comes to mind to a lot of people. But it's quick and easy. It's efficient. It doesn't take that much resources. You don't have to fire up the whole GUI. It just looks at a package and gives you the output. But for me, the most important part is post-processing results. I mean, you can get some fields out of a trace file and you can post-process them to anything you want. So while the GUI is very powerful and it's interactive, it doesn't give you that flexibility. It's fixed functionality. The CLI, combined with other tooling, gives you the flexibility to create everything you want. Also, an important part is automation. Maybe you want to do a certain analysis every day. That's automated in Tshark and put the output files or you mail it to people or whatever, so you can automate things. So in the end, the CLI is not only useful when you don't have a GUI, it's a whole different, it complements Wireshark. So how can we use the CLI tools? Well, and I'm a bit focusing on translating information from Tshark into something else. So it's not really focusing at using it when the CLI or the GUI is unavailable. So if you want a certain output, you have to know what do you want from the output? How does it look like? What information do you need to extract from the trace file? So think that first before you start doing stuff. So you have to visualize the output. So what inputs do you have? What data sources? It might be trace files. That's what we're talking about now. But there might be other sources as well. Combine them. But for now, we're focused on the trace files as input source. You have to know what the output formats are. So you have to know how you can translate it from the output format of your data sources into the output that you need for your analysis. And then you have to know what tools do I have available to get from the output from my sources to the output that you need. So what can they do? Browse the web pages and look for unknown options that you haven't seen before. So this session will focus on this whole process. We have a trace file, we need some information, and we have some Wireshark CLI tools and some shell scripting, and we try to mix them together to get what we want. The most important part is practice and experiment and be creative. That's when you, so if you think, oh, I need this, but I don't know how to do it, just look at the man page, just experiment a bit, and then you will get to it. So what tools are available from Wireshark when you install Wireshark? First of all, we have Tshark. Everybody used it maybe. It's the full version of Wireshark, but just CLI. So this full packet decodes. We have dumpcap to actually capture packets. It's being used by Tshark and Wireshark. Capinfos to give us quick overview of what is contained in the capture file, and the options within Capinfos. The information that it gives is extended every time. I think a month ago, some extra information was added to it as well. There's now file hashes, so you can compare if the file has been altered or not. So it's quite interesting. Then you have Editcap. You can use to change which packets are in a trace file, but you can also use it to alter packets in the trace file. We'll look at it later. Mergecap to combine separate files into one. Wireshark, which is used by Pilot to get packets to Wireshark really fast. It's not covered in this. I haven't used it actually, so I really don't know how to use it. And those being used by Pilot. So what's Tshark? Tshark is the CLI version of Wireshark. It's very similar to Tshark, but it's stateful. It keeps the state of every packet just like Wireshark does. It does reassembly, and it does all the protocol decodes that Wireshark does. So it gives you full visibility into your packets. It uses dumpcap as a capture engine, just like Wireshark does. And there are quite a few standard options. I'll run through them just quickly. -D gives you a list of interfaces that you can use. -I, you can select an interface from the list that you just saw. -C to limit the amount of packets that is captured. -N to disable name resolving. -L to make it flush every packet out when it comes in, not just wait for the whole buffer to fill. -F to select the capture filter. -R to use the display filter. -S to use step length, and -W, which is one of the most important ones, to write the capture to disk, and -R to read the packet from disk. So look at the man page or Tshark -H to see all the options. -N disables name resolving. If you're doing Tshark, just disable name resolving. It slows things down, and I don't use it that much. And you can change the timestamps with -T in that format. If you standard, it gives you seconds since the beginning of the capture, but if you want to have the absolute time, just do -T A, and it gives you absolute time. One of the things that is nice about Tshark is that you can also do decode as. If you're analyzing a stream that uses the port 8080 for HTTP, you can use -D TCP port equals 8080, and you have to dissect it as HTTP. Because in the GUI you can select that as decode as and stuff like that. But you need that if you're doing analysis on HTTP on a different port. So keep this in mind as well. Also, all the preferences are shared between Tshark and Wireshark. So or if it's on the same system, all the preferences that you select in Wireshark, they're saved in your preferences file. They will be used by Tshark as well. If you want to override one of the preferences and you don't want to change the preferences file, you can use -O and a preference and a value. You can use Tshark -G current prefs. It's not on the slide, but that will give you all the current preferences. So you can grab in there, or we'll use it in one of the labs to change the setting. Well, Tshark output formats. Normally you would get normally you get one line for each packet, and we'll use the default columns that are in Wireshark as well. But if you use -v, capital V, it will give you full protocol decodes. So if you need to look into a packet, see a cookie or whatever, use -v. And you can also add the hex log of the packet with -x if you need it for something. Then if you have some tooling that can read XML files, you can also export all the packets with the full decodes in XML. And that's the -t, capital T, PDML. I'm not using that much, but if you have already some tooling that can read XML, this is the way to go. You will see that it will create a lot of data, because every packet will be tagged, every field in the packet will be tagged with an XML tag, so it's really bloated. One thing that I use a lot is the fields option, so -t fields. That will give you the possibility to select which fields you want in your output. And that's what we're going to use when we pipe the output through other commands. Then there's somewhat unknown options to Tshark, which are the -z options. Those create statistics. There are a lot of statistics in Wireshark. You can do a protocol hierarchy, just like you do there's a lot of statistics in Tshark. And the -qz, the q is for not outputting all the packets, so it's quiet. It just gives you the statistics. And this will give you an overview on what protocols are in the file, just like the protocol hierarchy in Wireshark does. Conversations, just like in Wireshark, you have a lot of options for conversations. You can look at the Ethernet conversations or TCP conversations, UDP, IDP, and you can do that from the command line as well. I/O statistics, just like the graphs that you can create in Wireshark, you can use I/O statistics. It will give you a table with all the values, which you can export to Excel or whatever to create your own graphs. So that is really powerful, just out of the box functionality from Tshark. Let's see. Dumpcap. Does anybody know why we created Dumpcap?
Performance.
Oh, that's the main purpose was preference separation. It's you don't want to run these millions lines of code with root access. Well, if you have to capture, you need root access, or at least some elevated access to the capture interface. So what we did, I think it's about 2 years ago, is we separated the capturing engine from the displaying engine, and that's where dumpcap came in. And the nice thing about this is that you can use dumpcap on its own as well, and I use it quite a lot. The options are similar to Wireshark and to Tshark, so you can use the same options that you use for Wireshark or Tshark. And there's two gains from that. It's very fast because it just copies the packets from the network to disk. It doesn't do any analysis with it. It filters them, writes them to disk, and just goes on. And it's stateless. It doesn't keep state. It's just packet, disk, packet, disk, packet, disk. It doesn't do any analysis. While Tshark packet, I have to look at it. I need to interpret it. I need to reassemble it, and then because it doesn't keep state, you can have it run forever. I've been using it in some situations for months in a row, using a circular buffer, like a ring buffer. I don't know, this is readable, it's kind of slow, kind of small. So what you do is you make a ring buffer of 16 meg files, and you keep 1,000 files. This will create a 16 gigabyte capture buffer, and it just keeps rotating. And once the problem appears, you stop the dumpcap and you go look to the packets where you are. I don't know who was here in the session about the SDMS this morning. That's really great because that automates this whole thing. But you have to pay for that. So I think it's worth it though. I don't want to. You want me for case here? So Capinfos, what does Capinfos do? Capinfos just shows you, this is actually an old version, I didn't want to make another slide, but this is the old version of Capinfos. It gives you a lot of information like the file name, type, how many packets are in there, the file size, what the file size should have been if the packets were fully sized, the duration, start time, end time, the data rate. So there's lots of information that you can get just from Capinfos, and it's really, really quick. You can also get some specific info. Like, I only want the start time and the end time. So it gives me, from each trace file, the start and the end time. In 1.4, there's the option to use -t with that, and it will give you a tabular data. So it will show you file name, start date, end date in a table. It's very nice. We will use it in the labs. So Editcap, to edit capture files. You can use to select packets. For instance, if you want to have a certain time frame from a capture file and save it to another capture file, you can use it like this. So packets after this date, but before this date, from this file, write them to the temporary file. You can also automate that with a script, and then you can also use it to split files in chunks. If you have like a very big capture file and it doesn't read in Wireshark or it doesn't read in Tshark, just use editcap -c for the amount of packets that you want in each file, or -i if you want to use intervals. This is a 60-second interval, so it gives you files with 1 minute of data each. Or one of the most important features is you can remove duplicate packets. If you by accident spend the whole field on ingress and egress, you have every packet twice in your trace file. You can use editcap to remove the duplicates. It's very useful. You can also use editcap to change packets. So not only select them, you can change them. You can, if you have captured full-size frames and you say, okay, I don't need it anymore, I just want to have the packet headers, you can just change it. Or you can, which we're going to use, I don't think I'm going to use that in the examples, but you can also use it to change the timestamps. If you have like two traces from two different points and they were not synchronized in time, you can use editcap to synchronize them. So you have to calculate what the difference was between them, look at ICP packets or TCP sync packets, so you can calculate what the difference was between the capture files, and then you can change one file, and after that you can, let's see, after you can use Mergecap to merge the files to see how the packets relate to each other. Something I haven't used that much, but you can also change the link layer type, especially if you use a user-defined link layer type. You can also use Wireshark to say, okay, I need after the ethernet header there's like 8 bytes of some header that I don't understand, but after that IP starts. So look at that location and start decoding as IP. It's going to be handy sometimes. I haven't used that much, but I know people use it that way. Or you can change the file type if you have it in decrypt file format and you want to give the file trace file to somebody else that doesn't understand decap, then you can change it to, for instance, that's a general sniffer format. Like I said, Mergecap can be used to merge files. So you can merge them based on timestamps. It will look at each timestamp and put them in between in the output file. Or you can use the A option to just concatenate files. I checked whether that was a big performance hit if you do it like this, but it wasn't. So mainly you just use this. Then unless the packets are not in chronological order and you do want to put them behind each other, then you can use the concatenate option. So if you need any information on the CLI tools, you can always use the -h for what options are available. So look at that and check once in a while if there's new options, because it's being worked on, well, not 24 hours a day, but it's being worked on. So once in a while new options come to the CLI tools as well. And they're not really well documented. But And you can read the mem pages for extra information as well. So any questions so far? Okay, then we're gonna do some hands-on. Take the laptops on the files, and also the PDF with the instructions are on this URL. So download the trace files and the PDF. What we'll do, I have a few cases. Let me show you.
Go back to the URL.
Oh, sorry. Let's see. There it is. I hope the server can cope with that. 50 people downloading at the same time.
What's it now?
Do you have the files?
It's downloading.
Okay.
Your statement earlier is interesting. You said it tongue in cheek, but with some intricate scripting, you can mimic a lot of what the tool that the session prior was showing, the pilot.
Yeah, of course.
Yeah, you can do.
So that's the beautiful part about the case for it. Is that it integrates all the stuff in one box and in one GUI, and it does it for you.
And then if you're pretty versatile in Excel,
Yeah.
you can kind of do some neat things.
Yeah, but you have to do it yourself.
Yeah.
It takes time.
Yeah, but it's neat though. It's nice to think through something.
Yeah.
It's powerful.
Does everybody have the URL? I can show you the cases and walk you through a bit. Well, the goal of this session is to explore the Wireshark CLI tools.
That's this neat. Yeah, that's really neat.
So this is the PDF file that is in the zip file. So walk you through them. First case, we're just gonna look at the different output formats of Tshark. Then we're going to use some decode S information to see that you can actually decode some traceful with a different port as well as something like port 1, 2, 3, 4, and that's HTTP traffic. We're going to look at preferences, and also we're going to look how to make the selection of packets with let's see, with different options. Let's see. Then we're going to use the minus set options to create some statistics, Editcap, and also Mergecap, or again Editcap, and in the end we're going to use Mergecap. Let's see. And then we're going to continue how to use the command line piping. So.
Go back to the URL one more time. I can't get
Okay.
the wireless.
There it is. The plan was to do this for like 10-15 minutes. If you don't finish, don't worry. You have time later on. So just to get a grasp of how to see the Tshark works and stuff. If you have any questions, just pop your hand or speak up.
Are you then going to do a demonstration of going through them? Or you do it as a group at that point after we've had
I can do that as well, yeah.
When you showed how to make the circular file, 16 main files and get up, I think 1,000 of those
Yeah.
files. Is there a reason that you made, could you just make one, I don't know, big file or too big for a cat file?
Yeah, it's a big process. So yeah, if you have, it depends also on the capture length, because it's not the amount of data that counts, it's the amount of packets that counts.
So if the problem happened, you would just kind of merge maybe 3 or 4 of the files.
Exactly, yeah. Mostly by the script to extract the session I need from all the files, put it in temporary files, and then merge them back together. Which is something we're going to do in that exercise.
Second, could you show that on the one bullet point you had was to get the timestamp format? There was -v CL. This is in the slide that one you showed just before this. It had get the timestamp format examples in Tshark.
It's pretty cool.
The slide is actually in the file you downloaded as well.
This one?
No. There was one after this slide.
For Capinfos or?
Keep going.
I think it's slide 10.
Slide 10.
Tshark, paren 1.
Oh, just. Then.
Okay.
What's the Hansen? What's the background of the question?
It had the example of type -v-cl, I think she said, to show the timestamp format. To see how the timestamp.
The presentation is in the PDF
Okay,
in
okay.
the zip file, so. I don't remember. What do you need this one? Capinfos.
No, maybe I was dreaming. I'll look at the present.
Yeah.
Do you also have to go through Tshark to Sigma, or can you download it separately?
You can use Tshark also from the Windows command. But the problem is that for these exercises it's okay, but for the exercise later on we have to use pipe the output through a Docker command, and then you need a bash shell, command shell.
Yeah, so Sigma will.
Sigma will do, yeah.
Do we need? So we can download the Windows version of Tshark and pull it through Sigma.
Yeah, exactly. Yeah.
So similar to Hansen's question, you talked about an option to in the CLI get your current set of preferences.
Yeah.
Well,
I can show you.
What was that switch?
Yeah, I can show you that.
Okay.
Let's see. This is one.
Okay.
That gives you a whole bunch of preferences. Well, it's pretty quick here, but. So it's 3,000 lines of preferences that you. What I usually do if I want to change a preference is I grab, for example, TCP preferences, and it gives me all the. Doesn't give me any TCP preferences this time. I guess because they're all default. But it should.
Is there a reason -G isn't in the man page?
It's used internally. I don't know why it's not in the man page, but
It might be.
it might be. Yeah. I don't know how I discovered that it was there. But see, all the TCP things are still default.
Perhaps still should have returned this though.
Not if I do it like this.
If you do the -H, it shows the.
You do it like this.
Just have a quick question for you. Tshark minus X to do the hex.
Yeah.
Is there a way to suppress that summary line all the way? I'm trying, I can't.
So let's see. Tshark Editcap minus X.
See how it's got 10, 11?
Yeah.
That screws up text to PCAP.
Yeah.
How
So
do you-
what you can do is you can
You have no problem, right? No. Which one are you? Yeah, sure.
you want it like that.
Show me the regex again.
So what it does is
That's exactly what I would have done.
yeah. So what this means that you have to look at the beginning of the file or of the line,
Right.
and it should match a character from this range. So any line that begins with a digit will be printed. Every line that doesn't begin with a digit will be.
But why doesn't it match like the line number 1?
Because
there's
it's-
space.
There's a space in front of it.
But you don't.
So if the packet count comes up and the lines start with a number there as well, then you have to do something a little more fancy, like.
And then how do you add a character turn just before 0000? I can figure that one out.
So if you want exactly four numbers, 4 digits, and then a space, you can do like this.
Yeah, no, I was just.
I just looked it up in Windows, that's what it says.
It's not. Let's see. It should be. There's 4.
Yeah, that's what we're thinking.
I got it. Okay, thank you very much.
You can do it like this.
Try egrep instead of.
Yeah, you have to use ego. That's the wrong.
Let's see if we can work on it.
There you go. So it's egrep is extended grep. It uses extended regular expressions. If you want to have the, you can decreate now.
That's what I was.
So I think we have. How far is everybody?
It's good, man.
Yeah.
It's good.
So we continue the theory and then practice this later on. Later. Yeah, because there's some people that don't have laptops. Okay. So what shell commands can be used to enhance the output that we already have with the standard Tshark options? Well, I heard somebody said grep. Any other takers? What have you used so far?
You could use awk or sad.
Blok, sad, Perl, yeah.
Fortran.
Ribbing.
Fortran. Okay, give me an example that you use Fortran. Did it work to get the summary lines out with Fortran?
7.
So you can use some bash internals like typing the command output, or you can redirect the output. You can use a loop to go through output, or you can The very useful one is the command line substitution. So these are backticks. So these are apostrophes going backwards. And what it does, it just gives you it executes the command, and the output that's from the command is used as the string in that place. And we're going to use that in the examples. Very handy cut to cut on what information you need from the line. Sort, unique, tr, translate, set and awk, has been said before. These are very, very powerful. You heard Capinfos tell you that he had an awk script of 300 lines to create the output he wants from the DTP tables. And it can be very useful. We're going to use just a small part of awk in this session. And of course you can use the output and do whatever scripted language or compiled language or interpreted language you want. We're not going to cover that in this session. So what happens when you pipe output from a command? So this command will show you all the files in the directory and sort it by timestamp, and it will give you the 10 most recent files. It's a very simple example, but it's all about building little blocks and use them together to create the output that you want. So here again we do the same, but instead of showing on the screen, we write the output to file. If you want to loop through things, you can use for, do, done, like in this syntax, which will actually show you 3 lines, and every line should contain one word, 1, 2, or 3. We're going to use that later on. Now we combine the backticks with the for loop. So we're going to look at which files are in my directory, give me the 10 newest files, and use that output as the input for the for loop, which will create output like the file name, the first line of the file, and then an empty line. Then it goes to the next file, the next file, the next file. So it gives you the first lines of every of the 10 newest files in the directory. It's a silly example, but it shows you how you can build, with little building blocks, you can build something more complex. I've never used it, just an example. If you want to use variables, if you need to use variables to store things, you can again use backticks to create output. So if you put this line within the script, it will create a backup file for each file in the listing, which is the file name with the extension .bak. What does cut do? With cut we can select parts of an output line. You can do it on a character index, so this will give you the first 10 characters of each line. You can use minus C 80 to 84 to get the 80 is till the 84th character. Or you can use it with an index in fields. So if you have if the fields you are interested in are separated by something that you know, you can use that. So in etc password, all the fields are separated by a column. So you can use -d column, and then I just want the first field for the username. So you can use that also to get information out of one line of information. Of course, sort is available to sort your output. Standardly it does it alphabetically, so if you don't give any option, then it gives you alphabetic sorted list. You can do it reversely, or you can do it numerically, and this is what we're going to use later on as well. Or you can combine them. Does anybody know what output of this command will be?
The largest files in the current folder?
Yeah, exactly. And not only the largest files, but also the largest directories. I use it a lot. I actually have an alias for top 10 to give me the top 10 disk space users in this directory. So if you look, where does my disk space go? Just use this and you see, okay, in this directory, this file or this directory takes up the most space. Unique. It will show you only unique names. So if I sort the names in a file, I will get all the names that are in that file, but it doesn't give me duplicate. If I'm interested in only the duplicates in the file, I can use the -d option. It will give me all the names that are duplicate in the file. Or one that I use a lot is, I want to know how many times a certain name appears in this file. So I use the -c, the count option. We're going to use that as well, I think, in the exercises. Translate or transform. It gives you the possibility to transform certain strings in your output. Like in the first example, 1, 2, separated by spaces. If you have something that doesn't like spaces, you can use tr, and then here's one space in between, and you change it to an underscore. So we'll remove all the underscores from your string and replace them with, or it removes all the spaces from your string, so replace them with underscores. Or if you want to encrypt something in a very simple way, you can translate all the digits, so there's a range here of digits, and I can change that to the letters A to J. It's not very useful example, but it gives you an idea what you can do. Another not so useful example, but it shows you what is a house. If you translate that, these characters to these characters, all the vowels will be one shifted, so creates a mess. You can also use tr to delete things. For example, you can delete all the spaces, so every word will be back together. Or you can remove all the vowels, or this one is actually very useful. If you have a text file that is DOS formatted, so it has a carriage return before the new line, you can remove it with this command. This is a notation to use an octal number, and the octal number for 15 is the carriage return. So you talked about set. It's a stream editor. Look at the man page. It's really, really extensive in the possibilities. I mostly use the -execute substitute option, because I can substitute things in strings, which means I can delete stuff. If I substitute this pattern for nothing, it will be deleted. Or you can replace the stuff. Or you can do it a little more complex. I'll walk you through this. It will look at the beginning of the line for any character multiple times. And then these backslash bracket or bracket parentheses will tell you, okay, everything between those, keep that in a pattern buffer. So it will keep this, the thing that is messed with this string, it will keep it in the pattern buffer. If it's a fixed string, it's not really useful because it's a fixed string. But if you use regular expressions, like give me a string that looks like 4 digits, dot, 4 digits, a dot, 4 digits, that's a credit card number, you can keep that even though you didn't know what the credit card number was. Then some other information, and then again something that we look for, and then some other information until the end of the line. And we're going to replace that with the first string that we saw, so this back references to this one, and the second pattern that we wanted to keep was references to this one. It's a bit complex, we'll have a look at it in the exercise. Awk, also very, very powerful. What it does, it processes each line and executes a script on that line of information. And you can keep state, you can do anything. Something that I've used quite some times is, for example, give me all the nested information, look for TCP sessions, print the state of the connection, if it's a threadless, SYN send, SYN received, listening. Sort the outputs, so there will be a sorted list, and then after that you count each occurrence. So that gives me a list of how many established sessions, how many sessions in SYN send or in listening mode. And for the examples later on in this session, this is very useful. If you have a Tshark command that outputs port numbers, and you pipe them through this all command, what happens is it will print a string, this string separated, but it's not initialized yet, so it doesn't print anything. Then it prints TCP port equals the port number of the first line, because this is the first field of the line. Then it says separator needs to be the OR sign. So the next time, for the next line, it will print separator. Hey, that's the OR sign. Then TCP port again. So you get a filter from all the TCP ports. We're going to use that in an example, so you see how that works. Well, scripting you can use anytime, any language you need. Whenever command line piping is not enough. You can imagine that if you want to do complex things, that you might have a one-liner of actually a whole screen. It's not very useful, so make a script out of that. So you automate stuff, or and you can use your own language to do that. So use the language that you're familiar with. And this gives you great flexibility. We won't go that far this session. So some examples. Using command line piping. If I have an HTTP file and I want to know how many times a certain response code is being generated, I can do that with command line piping. I can show top 10 URLs. Or I can extract TCP sessions with a certain cookie. And use scripting, you can extend on that and give me all sessions for a certain user, which uses certain cookies, and put them in the file. I'll show you how these work. So the first example, if we want we need an overview of the HTTP response codes. What's the output? Well, I want to have a table with the response code and the amount of time that it occurs in the trace file. What do we have? Just a trace file. How would we go about doing this? What steps do we need to take to come from a trace file to have this output that we need? What tools are we going to use? Tshark. Good point. What else do we need? We need to pipe the output. Yeah.
You can print the columns using awk.
You can use awk, or it might be easier. Let's see what step we can take. First, we're only interested in the HTTP response code, so we need to make Tshark only output the response codes. Secondly, we need to count them, and we have to make a table out of it. So those are the steps that we need to take. How do we do that? So I have a trace file with TCP traffic. Oh, this is not the file I want to use. So there's a lot of HTTP traffic in this trace file. So we first need to filter on HTTP responses. That gives us a little more information, but now we only need the response code. You can use awk to do that. It's a good option, but I prefer to use the -t option with the fields because I can exactly select the field that I want, which is the HTTP response code. So now you have a list of all the response codes. So how can we make a table out of this? Okay, I'll do it away. First we sort them, so we have a sorted list, and now we can use unique to count them. Count. There's your list. I've got 103 200 OK messages, 12 302 redirection messages, and 9 content not modified messages. So in a few simple steps, we come from a trace file, information we extract from the trace file that we need, we post-process it to the the format that we need. Actually, Wireshark can do this because it has a table, but you can do this on any field. I mean, my examples are HTTP because most people know the HTTP protocol, so it's kind of more easy to grasp the concept. So what was the final command? Well, you saw the command. So what have you learned? To use the -t option to extract the fields that we want. And we used sort and unique to post-process the output. So the second example is a little bit more complex. It's to get the top 10 requested URLs. So I want to have a list of all the URLs that have been retrieved. And I want it in a sorted list with the requested URL and I count how many times it was requested. What's the input? Again, a file with HTTP traffic. So this one gets a little more complex. Let me see. I prepared them for easy access. So first we look at all the requests, and we're gonna print the host that was requested and also the URI, so that the file with on the host. I use -c20 if I'm developing something like this. I use -c20 just to get a limited amount of output, so that you don't get overflown with all the output. And what we see is that this is not really the URL that was requested. There's a space in between, there's no HTTP in front of it, so you also see that in some URLs there's a session ID that we don't want to see in the output, because we're not interested in each user session, we're interested in the URLs behind the question mark. So we need to post-process this. So first of all, we're going to remove the cookie. How can we remove the cookie? Which commands should we use? Or can we use, because there's always different ways to do things. Set. I have set somewhere in the... Oh, so if I... So now the session ID, the PHP session ID is gone. It's the login.gif here. It's gone. So how did we do that? We used set -e and substitute everything from a question mark till the end of the line, and substitute it with nothing. So that will delete the question mark and everything behind it. So now we're one step closer to what we need to do. Next, we want to make the URL seem like a proper URL, like http://home.urenet.nl/ without any spaces. So we're going to use set again for another time to create that. And this actually does not work because the /t, it works on Cygwin. The set version on Cygwin can't understand this, but on my Mac it doesn't understand it, so I need to remove that and change it to a real tab character. Oh. If you do Ctrl-V and then tab, it will insert the real character. So actually there's a tab here, it shows as a space, but that's the outline of the... So now the URLs are the same, are proper. How did we do that? Again, we execute a substitute command. But this time we don't use a slash as a separator because we need to insert slashes later on. So we use the dash character as a separator between the fields. So what are we looking for? We're looking for everything in the beginning and keep that in memory. Then a space, then everything after the space till the end of the line, and keep that in the second pattern buffer. and we're going to replace that with http colon / /. That's why we use hashes, because otherwise we should have escaped these slashes. And we put the first field and the second field straight after one another. And that gives you this output. So now we're almost home. What do we need to do now? We needed the top 10 list. So we're going to sort it. So if we sort this by unique count, and now we have to remove the minus C20, because otherwise it will give me only 20 packets. So this is not a top 10 list yet, this is a count of all packets. So we sort it again, exactly. But this time we do it reversely and numerically, because then we sort on the first field reverse numerically. And we're only interested in the top 10, so we need only the first 10 lines. If you use the head or the tail command, it standardly uses 10 lines for output. If you want top 25, you can use minus 25. So this is my top 10 list of URLs that were requested in this trace file. So again, it's step by step from the output that you have, transform it into something new, transform it. And it's all little building blocks.
Question: have you ever written something where it kind of tracks a session, like the SYN, ACK, and the overall total time it takes for that specific transaction?
Yeah, I've done that, but you can't.
Yeah,
it doesn't work with this. I use a Perl script for that. I wrote a Perl script that for each TCP session gives me the duration, the packet count. For each packet, it draws like the capital S for a SYN one way, lower S for the SYN the other way. You get a nice overview of the TCP sessions. So it's possible, but it takes some time. And I did that in Perl, and I used the Tshark output, and I put that through Perl to get that output. Yeah.
Was it like streaming to that, or was it? Did you process the Tshark file?
I think I streamed the file to it, so you can read a file or you can just do it
stream right to it.
Yeah. No, actually, I had to, it is not streaming because I first process all the packets and then I keep the session state in a table, and then afterwards, if I process all the packets, I would generate the output. So it wasn't streaming, unfortunately. Okay, back to the. Any questions so far on how to do this? Is it clear, or does it need some more? So what steps? Oh, this is what we're going to do.
So I have one quick question. When you you can do like conversation lists and statistics and all that, right?
Yeah.
Is that exposed in the Tshark command line? Like when you do the conversation list, it gives you source destination, and duration is one of the columns. Do you know that you can get that from Tshark?
No, the duration is not in the Tshark output. No. For the packet decodes, it uses the same engine, but for statistics, there's a separate engine for Tshark and a separate engine for Wireshark.
Oh, I see.
So the output is kind of different. It's something on the wish list to put that in there as well, because it could be very useful. Okay, the final command that we used. See that I made this red because different set versions use some versions accept this, some versions you need to insert the proper tab character. So what have you learned? You can remove unnecessary info. You can use a transformation, and you can use different separators for these cards if you have to use the. So normally you would use a slash as a separator, but if you have to use a slash somewhere in here or in here, you can use another character to use a separator. And To make a top 10 list, you can pipe to sort, unique bin count, pipe to sort again, reverse numerical, and then only show the top 10. So now we have a problem with, we know that a user is having a problem with a session and there's a session cookie, but there can be multiple TCP streams with the same session cookie. So how can we extract this whole session from this user, so a user-based session? So the problem is, we know the user uses a certain cookie, but it's split across multiple TCP streams. And we want to have all the data. So this is the output that we want. We want a new trace file with all TCP sessions from this user when it used this session cookie. So how can we do that? When we have, of course, again, a trace file with HTTP traffic. What steps do we need to take? Any ideas?
Find the streams that have that cookie.
Find
the streams that have the cookie.
Exactly.
Display it.
Yeah. So first, we need to select which packets contain that cookie, but we want the whole TCP string. Not only the packets that contain the cookie, because we also want the responses, which don't contain the cookie.
So the source destination.
So yeah, source destination, or we need to have a filter for that TCP stream. So what we can do is we can, in this trace file, it's one server, one client, so only printing the port numbers is enough. But if you have a complex trace file, you might also need to print IP addresses and make complex filters. In this trace file, the port number is actually identifying a certain TCP session. So we can use the port number. And now we need to create a filter with all these port numbers, which we can use as a read filter for a second Tshark command. And then we can use that filter to extract all the TCP sessions that we need.
Couldn't you use TCP stream?
Yeah.
You've done that.
Do you remember?
The stream index is kind of funny. I'm the one that created that, actually. And because the stream index is not really a TCP stream index. It's actually a conversation index. So in Wireshark and in Tshark, there's lots of conversation data kept in memory, and that's all kept in memory with an index. And I was thinking, okay, it's just an index, so let's use that one because it's unique, but it's not sequential. If I wanted to make it sequential, I should have used another index, so it increases the memory footprint, and you need to keep track of that index. So I thought, let's just keep the index that it's there, although it's not sequential. It is sequential, but there's gaps in it if you look only at TCP. But exactly, you can, for this example, you can use TCP streams, but this example is actually built, I used this presentation in a not an interactive form 2 years ago in ShardFest, and the TCP streams wasn't there yet. So it might have been a better option in this example, yeah. I'll change my slides, thanks. So then we need to save the package to the new capture file. Oh, back to work. Let's see. So what I did here is I read the example file, only HTTP requests, and only the ones containing that have a cookie containing the PHP session ID. Well, you see that those are matched for quite a few sessions. This can be one TCP session, or it can be multiple TCP sessions. So let's see if we take a TCP port. So you see that those are multiple TCP sessions. You can also do that with TCP string. So actually there's no other traffic in this trace, so these are the stream indexes. So I'm going to change that to stream. Let's see if that works. So now we have all the stream indexes for the user that
Sorry, can you re-explain what is a TCP stream?
TCP
So they
stream,
are part of the same TCP station, or it's 10 TCP stations here?
TCP stream means that a whole TCP station has a stream index, and that's just a number coupled to that stream. Because you can have two TCP streams or two separate TCP sessions which uses the same ports. So if the port numbers are reused, then you can't distinguish which one.
Okay. Okay, if your PC uses the same source TCP port after a fin, and
Yeah.
you establish a new connection with the same.
You see that in low balance environments a lot, that the port number is being reused.
Okay.
Actually, I think this is a problem, because they're now sequential, and that's because the filter already deleted all the other. So it doesn't see the other streams. So this won't work, actually. So we go back to what it was. Let's see, we go back to port numbers. And now we need to make a filter for these port numbers. As we have seen in the slides, we can use awk to do that. Oh, let's see. What did I do? Oh, already on. So now all the port numbers, I also removed the -C10, as you can see. So all the port numbers are now put together into one filter. And you can use this filter in Tshark to select all the streams that you want. How do we do that? Well, we can use backticks, one in the end and one on front, and then we use Tshark example of cap, and we use the output from the second Tshark command as the filter name. I think I have a problem here. So now it gives me all the TCP sessions which contain the cookie. And of course we want to write it to file, so now it's in a new file. And you can do that on any information that you want. So back to what have we learned? So the final command, if we work from inward to outward, we use Tshark to create all the port numbers. We use awk to transform that into a filter. And then we use a second Tshark command to use that filter to extract the packets that we need. So what have we learned? To use backticks to use a command that creates a filter, and then use that filter in Tshark. Then we can use a filter like this, and the problem with a filter is if you don't, if you just use TCP port equals something, and then or, and then the next, then the last port will have an or, which creates an invalid filter. So the creative way to address that is first print nothing, and then after the first time make that nothing an or. So the first one will not have an or, and then every other port has an or. So the last example, and then you can do your stuff, is if I don't know yet which cookie was used for this user when the problem appeared, but I know the username. So now I must make a link between the username and the cookies, because there can be two or more sessions from the same user. So I want a new capture file with all data for user XXX. I again have an HTTP file. So what do we need to do now? How can we start? What's the missing link between the last example and this example?
The user.
Here user.
That's the same sorted by user.
Well, you need to have a list of all the sessions for a particular user.
You need a key for that user. How are you identifying it?
Exactly. So
IP?
first we look for this a user ID and then print the session cookie for that user ID. So if there's multiple, we'll have a list of all the session cookies that was used for this user ID. And then per cookie, we're going to do the same thing as in the last example. And then we're going to merge all those output files into one file again, and then we have all the sessions in one file. So how does that look? How are we with time? Well, it's still 20 minutes, so we're fine. Let's create some space. So what I do here is I read the file again, request, and I know that the username was Tshark -1. If you have a more specific place where the username is in the trace file, you can use that. But in this trace file, it's enough to just look at the username. And then you print the cookie. So we have, this is the cookie for, this are all the different cookies that were used for this user. Let's see, is that correct? Yeah, so the cookies only been only in the login page. We only look at the login pages now because that's the only ones that contain the username, and we know which cookie was for the login page. So we can loop through, again we use backticks to make the cookie list, and then we're going to loop with a for loop through these cookies. And what you see here is that actually this for loop is mixed up by this space here, because this space separates these two, so it thinks this is a cookie, that's a cookie, that's a cookie, that's a cookie. So we need to do something about that to solve that issue, because we just want a cookie. How can we do that?
Can you cut the line?
Yeah, we can cut the line. We can select the field that we want from the line. So we can use awk to do that. We can use tr maybe to do it, or we can use. There's several ways. The ones that I have in my example is we can use cut. So what this command does is. Let's see, some 2 lines, but cut minus d space, so we look for space as a separator, and then we use the second field. So if you go back to this one, this is the first field, space, second field. So we print just the PSP session. So now we have the sessions that we can use as a filter for the command that we used in the last example. So we're going to do. So what does this do? I do the same, but now I create a temporary file. That's a file name for my temporary file later on. I echo the cookie, and I just want this as a file name, so I split the cookie into this part, and I only keep the second part. So I have a file name that's actually only the cookie name. So what we'll do later on is we're going to process this cookie, and we're going to process it to this file name. Now we can extend on that by implementing the command from last example. And if you write it in a script, I'll close the script. Oh, I can do like this. That's my cheat sheet. If you write it in a whole script, then you can say, okay, extract user and then a file name and a username. So those are the command line options for that script. So extract the file name, extract the username. Again, we're going to look for the cookies, just like we did before. I'm going to create a temporary file name. I'm going to tell the user that I'm working on something. And then this is the command from the last example. And now we substituted the file name with the file name that was given by the command. And we changed the cookie, the hard-coded cookie name to the variable from this loop. We're going to write these files to a temporary file name, which we created here. And after we're done, we're going to use Mergecap to write to the username.cap with the temporary files, and then we're going to remove the temporary files. So if I execute that script, let's see. So I have the script here. If I'm correct, I don't have the script here. I placed it. So I have to use so what was the file? Example.cap, and then the username was Tshark minus test1. And I've created the file name Tshark minus test1. So now you have automated an action that you might want to do many times when you're troubleshooting something.
Quick question.
Yeah.
Is there any way to process a dumpcap file like real time for a trigger? Like no,
Okay.
you've got to take that full file and
Yeah. It's one of the wishes on one of the things on the wish list to have like a capture
like a
stop
filter
condition and a capture start condition. That's not implemented yet. So this is the final script. Again, it extends, but the basic steps are the same. So again, we use the command from the last example, and we put some other scripting around it to create this this file. Let's see, what time is it? I have to give you some time to work on that. So what have you learned? To use for, do, done. We have used a variable name for the temporary file name. We have used cut minus d with a field separator to extract a field. We have used Mergecap to merge the new files together. Oh, that was it. That's what we learned. So again, the files are on there, and I think it's case 8, 9, and 10. So I guess you should do it yourself now. Case 10 is a real challenge. I just give you the output. So don't worry if you can't make that. If you have any questions how to do that, just come to me or mail me or whatever. See how far you get with the examples.